Can everyone hear me? Yes. All right. Hello, everyone. My name is Vijay Samuel. I do architecture for eBay's observability platform, and I'm here to talk about distributed tracing. All the warning signs were out there. So I've been with eBay for roughly 12 years now, fresh out of college, my only job. I definitely think it's a God-given blessing for me to have had an amazing career at eBay. And observability at eBay is an incredible challenge for the sheer size the company is and the kind of complexity that we have to deal with. Talking about distributed tracing is definitely going to be interesting in context to eBay. So what is tracing? I pulled this definition right out of the OpenTelemetry website. Traces give us the big picture of what happens when a request is made to an application, whether your application is a monolith with a single database or a sophisticated mesh of services. Traces are essential to understanding the full path a request takes in your application. A very standard definition that we probably are all very familiar with right now. What is the scale of distributed tracing at eBay? So we do a standard 14-day retention with 400 billion spans a day, which roughly translates to 5 million spans per second. And this is handled by 3,000 odd provisioned CPUs and roughly translates to 200 terabytes of storage. So tracing is a 4-point problem according to me. What everyone needs to solve. The first one, end-to-end instrumentation. Make sure that you're able to get every developer to instrument. Ensure that context propagation is perfect, and ensure that the instrumentation is judicious. Why? Unless context propagation is not done right, then you would have broken traces, which will not give you the full picture. If the instrumentation is too much, then it's going to be a very huge waterfall for people to make any sense out of. And again, if there is one team that sits right in the center and they're not doing their instrumentation, then there's going to be a gap there. Next, you build or buy a platform. There are 3 common routes that people go through. They either pick a vendor, pick an open source project, or basically pick a database that works for them and then build an entire solution on top of it in-house. Optimize for cost, identify what's the right sampling percent to deal with, how much to retain, how long to retain. That basically decides how expensive of a pillar tracing is going to be. And finally, how am I going to use it? Am I using it for triage, root cause analysis, performance tuning? There are many other reasons why you would be using tracing, but what exact use case you are having in mind can determine how the architecture could potentially look like. So I thought I was wise beyond my years, and I was like, okay, I have this all figured out. I've heard everyone talk about it, how they rallied every team to do this. I'm not going to go down that direction because I know better. Knowing all the problems, we had everything planned out. So the first problem, end-to-end instrumentation. We'll adopt OpenTelemetry. It's the standard now. If we use it, there are a bunch of people who are going to give us some free telemetry because everyone is adopting OpenTelemetry to do their instrumentation. Optimize for mass adoption. Do as little as possible to make sure that you're covering a majority of the applications. And finally, if we have a way in which every development team does not have to instrument, then that's the best path forward. So let's talk about each one of them individually. OpenTelemetry is the industry standard now. They have SDKs for all the commonly consumed languages, and they're official SDKs, not community provided or community maintained SDKs. The semantic conventions, after a lot of evolution, is a standard now, which everyone is consuming, whether it be people are doing their own instrumentation or off-the-shelf products that you're consuming that has OpenTelemetry enabled on them. And finally, there is a collector that it provides, which has a plethora of capabilities. There's the standard analogies for the collector. It's a Swiss Army knife. It's like a bunch of Lego puzzles. You can put them together and craft whatever you want. So a lot of goodness comes out of OpenTelemetry. So by hopping on the OpenTelemetry bandwagon, we would get instrumentation capabilities and learnings for free. So part of the problem is solved right there. Optimize for mass adoption. So within eBay, we have the concept of a managed framework, and the managed framework constitutes anywhere between 80 to 90% of all applications that actually power our systems. So if we go for instrumentation on the managed framework and deliver it through that, then 90% of the site would be implicitly covered by the instrumentation that we are rolling out. And the framework team, they have this concept of a mandatory site-wide upgrade, which happens every month, which means that the time to turn around new instrumentation or instrumentation fixes is roughly 30 days. The beginning of the month, the upgrade kicks off, and by the end of the month, every application on the site would have essentially been covered with what we are trying to roll out. And what about the remainder of the 10%? For that, we basically go down to the infrastructure. We also have a service mesh, and which means that if we have tracing turned on the mesh, it means that you would get some out-of-the-box tracing there, support there as well. And finally, we make instrumentation optional for developers. So on the managed framework, what we are essentially doing is that all client calls, server APIs, and database calls, we have the instrumentation already implemented, and as long as the person uses the prescribed ways on how to define an API or make a client call or make a database call, then everything from the span generation to the context propagation, everything is implicitly taken care of. So by not involving developers, we can move a whole lot faster. And in a sense, it's actually quite true, because with roughly 8 to 10,000 applications that use this framework, that's a lot of teams to cover if you wanted to go and have them individually instrument every application that's out there. Build a platform. Pick a blazingly fast storage technology, and right now that's ClickHouse. So we took ClickHouse. One thing that we did different is that instead of having one large cluster, what we did is that we have a concept of what we call a ring. A ring can have smaller ClickHouse clusters that are there, and when spans come in, we look at the trace ID, we do a first level sharding to pick which of those n clusters to go to, and then we do a second level shard to figure out which exact shard number on the ClickHouse cluster to write to, and then it goes in. So that way we can horizontally keep growing the fleet without having to worry about managing larger and larger ClickHouse clusters. And make the APIs an open standard. So when someone wants to consume, we have the Jaeger protobuf definition implemented on our query APIs. So as long as you know how to query using Jaeger, you should be able to consume the data. So this is how typically a Kubernetes cluster looks like. So you have three flavor of applications that are there. One is a managed Java app, managed Node.js app, which basically use the framework that I just talked about. And you have generic apps, which is basically everything else. So if you're writing something on Go, you basically are treated as a generic app. You have OpenTelemetry collector sitting on every Kubernetes cluster. And every one bundle, the OpenTelemetry SDK, writes spans into this well-known endpoint within that cluster. And there is a gateway called our traces ingest, which can basically write to the trace store. In this case, it's ClickHouse. And OpenTelemetry collector also has the capability to write to our metrics ingest, which goes into our metric store. There's a traces query API which can query the traces, and metrics query for metrics, and all of this is visualizable through our console. So Sherlock.io is the brand name of our observability platform inside of eBay. Optimize for cost. It's okay to send less. I think like in quite a few of the sessions today we have heard we do 20% sampling or we do 1% sampling. It's okay to sample less on the head. Once data has come to rest, it's okay to eliminate even further redundancy to cut few corners on cost, and finally be able to scale with the traffic. And even if you take the shopping analogy, there are periods of time when people shop more versus shop less. So based on that, you're going to emit more or less spans, and it's good to expand and contract with that pattern to be more cost efficient. So what we do is the scale number that I talked about on the scale slide, it accounts for 2% of all the requests, and we honor the parent's decision. So basically this helps reduce the overhead on the application, because the more spans that you generate, there is a runtime overhead that we are all familiar with regards to the OpenTelemetry SDK. And given if the application has very high traffic, it negates the lag for the 98%, because end of the day we only care about the shape of the graph or the shape of the trend and not the exact values, because that's enough for us to do any kind of trend analysis that's required. And at this point, like when we started the journey, we were secretly hoping that we could at some point get to 100%. So when we started, we did a 0.01% on all applications, then we did 0.1, then 1, 2, and we're like, okay, maybe we'll go to 10 next, and then 20, and then see how farther we can go after that. Sure. Yeah, so we have all the spans that are there for the 2% that we accepted. Next, we can see what we can eliminate further. So what we really care about is spans that had a very high latency, or spans that had errors on them, spans that have particular attributes. Maybe there's a particular feature flag that was turned on, we need to be able to sample some of them. And for everything else, anything that completed with a status OK, maybe retain a subsequent 1% on top of the 2% that we are collecting. So what we did is we turned on the OpenTelemetry tail sampling processor in such a way that it samples, and whatever is being sampled we retain for 14 days, but the raw spans that we accept we retain only for 2 hours. And the query APIs are intelligent enough to say that, okay, if this trace ID was something that happened more than 2 hours, then it needs to look at a different table on ClickHouse. If it's within 2 hours, then it needs to look at another table. Scaling with the traffic is fairly simple. If you're familiar with KDA, there are rules against a metric store that's backed by Prometheus that you can issue a query against, and depending on what it sees, it can either grow or shrink based on what are the scaling limits that you want to set. And I said like traffic is very seasonal, and this basically allows us to scale as and when needed. So with regards to usage, a waterfall depicting every single hop in a system as large as eBay's, it's something that was never possible in several years of running either monitoring or observability. The mere fact that we were able to achieve something is a feature in itself, so take it or leave it. So, and then we lived happily ever after. My talk ends here. I would love to say that, but the reality is that we built a product that was so unusable. So let's explore what were the problems. So context is the first one. Even though we have a managed framework that will take into account everyone who follows the rules, there will be a few people who say that I'm not going to use the framework provided thread pool executor, I'm going to use my own, which will mean that the context of the parent would be lost and the waterfall falls apart there. So there are several other examples for that, but the thread pool one really stuck with me. Then low traffic. There are certain parts of the site which will not be as high volume, and for those, 2% was not enough. The collector is hard. Does anyone agree with me on that? Yeah, so the collector is hard to configure. There are so many ways that you can do it that many of them are very poorly performant. And it was a journey in itself to figure out what the right configuration would look like. Tail sampling in memory, which the OpenTelemetry collector does, is almost impossible to perfect. And that was one of the things that was spoken in one of the previous talks as well. Like, there are long running spans. Some run for a minute, 2 minutes, or even hours. Like, we have a team that's trying to model a multi-cluster Kubernetes deployment as a single trace. And deployments can go for minutes or even hours, depending on how much wait time you have between every set. So how do you tail sample for use cases like that? And the other part of it is that for us to be able to do true tail sampling, all traces from all regions need to come into the exact same collector, otherwise you're going to have broken spans, depending on what tail sampling decision was made. And in our case, every cluster does not have every microservice, and every call does not reside within a single region. So you have to shuffle spans across the network for us to be able to perfectly use the OpenTelemetry collector's tail sampling processor. This was a big one. Like, as we went through the process of tuning our collectors, making sure that they don't crash and whatnot, we noticed a lot of times where even if a single span is lost, then the entire trace is wrong. You're going to go through a wild goose chase, if especially you're relying on it during a very critical incident. And this is something that we saw with both our SREs and our developer community, that every time they see an inconsistent waterfall, their confidence on the product starts to diminish. And it was a journey in itself to figure out how can we restore the confidence. And finally, adoption. Developers and SREs are so comfortable using the tools that they have been using for such a long time that when you introduce something new to them, hey, this can show you everything in a single page. I like what I'm doing right now. Let me stick to that one. Given that we had a lot of bugs and inconsistent experiences, it became harder to sell. So that being said, some problems are unavoidable. Working with developers, we had to suck it up and start going to every developer saying that, hey, you're using a different thread pool executor. Maybe here is a new utility that we have written on top of the framework. Just wrap on top of that so that we can see the spans that we are that we'd like to see. So we created some utilities. Our SRE champions are working with the developer teams to see how all these gaps can be plugged out. And we are also doing a lot of learning sessions to convey the power of tracing, because without tracing, some latency based issues can take a really long time to debug, especially if there are hundreds of microservices within a single business flow. Like a few months ago, I was looking at one trace, had like 500 database calls in it. Like 500, that's a lot. But the reality is that with a complex site, only tracing is the way in which you can go about looking at these things. The next one is performance tuning. So numbers are everything. Identify the right way to stitch OpenTelemetry collector pipelines. Rinse, repeat until you are able to get to a point where you have zero drops. So I did a talk in KubeCon Paris, very extensive about this part, like what are the different permutations that we went through with regards to the collector and what model finally stuck. But this is an activity that everyone will need to go through, especially if they're using pipelines that are very fitted to their particular organization. For everything else, we created a new path. So I'm a big believer in simplicity. If the architecture looks complicated, then it means that I'm doing something wrong. So that being said, one of the big decisions that we took was to never globally route spans. It's okay for traffic for a given request to move across regions, move across Kubernetes clusters, but we will not try to catch them all. So what we did was deploy OpenTelemetry collectors that are local to every given Kubernetes clusters and have all the applications just write to that. We will enrich all of that with the Kubernetes metadata, generate red metrics, and we will write directly to storage. That's it. And we'll never do 100% sampling because it's cost prohibitive at scale. We have a logging platform which is trace-like, and it's roughly 15 petabytes a day. It's a huge scale, and it does not have the redundancy that the OpenTelemetry model has, where like every span has resource attributes and whatnot. Despite that, it's 15 petabytes. Replicating the same thing on distributed tracing might be cost prohibitive. And a huge portion of this was educating our developers, like, hey, you actually think that you need 100% samples, but you really do not need to. And a lot of times we have even had developers say, hey, I thought we were doing 100%. No, you have been on 1% for the last 2 years. You don't need it. And one of the nice side effects of not going to higher sampling rates is that lower sampling means lower complexity requirements. You don't need to do the dance to make sure that everything stays together. Be adaptive for low traffic. So there is the Jaeger remote sampler, which can negotiate a sampling rate depending on either what service is configured or what service operation, service plus operation is configured. So this is one of the ways that we are exploring to make sure all the low traffic APIs, we can basically treat them special and then do 100% for them, or something that makes more sense. And this is also useful in scenarios like, okay, you're doing a code roll, give a higher sampling percentage, have more signal, and then scale it back after the rollout is done. And the adaptive sampling would really help in these scenarios. This is one of the things that we learned through the experiments with the tail sampling. True tail sampling happens at storage. So we came up with this approach of how to sample using exemplars. Exemplars are decided upfront at the time of instrumentation. At the time of the metric generation itself. So if you have a histogram and you have like 20 buckets, every bucket will definitely have an exemplar. If you are modeling errors as metrics or error counts as metrics, every unique error type will have an exemplar as well. And all we need to do is make sure that when we move data from the raw table to the sample table, we are making sure that every exemplar that we have seen on the platform is absolutely moved into the sample table. So this was a very powerful concept, and I'll explain why when we go through the flow of it. The other thing that we did was delay the kickoff of tail sampling. So we give it a good 10-15 minutes, and then we basically go through the activity of tail sampling. So for most requests, this should be good. And for the unique use case, like the rollout scenario that I mentioned, we'll figure something out along the way. So this is how it looks. You have both OpenTelemetry collectors and for metrics and for tracing. The raw spans get written directly into ClickHouse on the raw trace table. And similarly, we have all the metric signals moving from the collectors to the ingest. We have an aggregator, which is similar to the pug that was talked about. Like everyone is doing it with different names, and then gets written into the metric store. So the span metric processor, what it will do is it will generate the red metrics for each span and then gets written into the metric side of things. So you have exemplars that are coming from here and from here, and what they're gonna have, what the aggregator is gonna do is it's gonna feed all those exemplars into something that writes all the exemplars which carry the trace IDs into another table in ClickHouse. And finally, what's going to happen is that a tail sampler job is going to come alive every every so often, and it's going to move the spans from the raw table to the sample table. So since there are red metrics that are being generated here and exemplars that are being created for each of the unique ordinals that are here, what's essentially going to happen is that for every unique kind of span status, HTTP status, cluster, service, operation, for everything you're going to have a handful of exemplars that are being generated, and this would truly be a representative sample of what you're seeing. Yeah, and this is something that is being actively explored by every other person in observability. So, and I strongly believe this. Tracing was always meant for machines, and the reason I say this is the 500 database analogy that I was or example that I was giving earlier. There are traces that can have hundreds or even thousands of spans, which are humanly impossible to interpret. So I think like a lot of the traces are meant for machine level consumption because they provide, assuming that the instrumentation is on point, it provides perfect call chains that can be traversed. And once you traverse, you can evaluate the health of every application in the call chain. You can do impact scope analysis. Again, you need call chains for that. And finally, you can do API performance analysis as well. Like given an SLO is being violated, okay, let me look at where most of the time is being spent again by traversing the call chain. And this kind of visibility is only available through tracing and is very suited for machines to come in and consume. You may not even need a large language model for this, just simple algorithms that can do some of this, but it's pretty powerful when you have this end-to-end picture that's there. More problems to solve. These are things that we are thinking about even now. So aggregate trace analysis, how can we do this? You cannot do it with a handful of sample traces. You might need a bigger pool, and the red metrics from span metrics processor alone is not enough. So, and the other interesting part is that we up to the point where feature flags became something that's very common. Call chains may be a bit stable, but with feature flags, call chains can be very arbitrary. And how does that impact aggregate analysis that you might carry? And the last one is like end-to-end observability. So we are also in the process of figuring out how we can do RUM. So how would you model a trace for that? If you're doing it by the session, how do you sample based on the session? And the session can be long running. How do you model user journeys? So a lot of things that are there in tracing that are still very unsolved that we are trying to figure out. So is or was all of this worth in the end? And I would say it's an astounding yes, because tracing is a very beautiful concept that helps you digest the complexity, especially in an organization as large as ours. So with that said, I'll take some questions, and thank you for your time.
All right, do we have some questions from the audience? Oh, we got one right here.
I'm curious if you rebalance your footprint strings when you upgrade your scan.
How do you rebalance?
We don't do any rebalancing.
Just let it live, man. Question.
Could you talk a bit about the cross-region flows and how do you solve that?
Can you talk about the cross-region flows?
So we have independent ClickHouse clusters in every region, and we make sure that we accept spans within the region itself. But at the time of query, we know exactly how many regions we have and what clusters are there through the help of the ring. So at query time, we basically do a scatter gather across all regions. But like we have indices that we create along with the ClickHouse tables, which essentially allow us to know exactly which shard within the cluster has a given trace ID or it has a given pod name and things like that. So we don't have to do like a full fan out on top of the distributed table. We can still do pointed fan out and then construct the trace afterwards.
All right. Any other questions? I think I see a hand in the middle of the back.
So for kind of like the tail sampling decision that you landed on with the exemplars that are generated by those like span metrics,
Hmm.
like can you give like a real world example of like the benefit of that versus like kind of the standard tail sampling process of just like regular latency error code and stuff? Like what's the kind of like benefit that you see with data land?
Can you give a use case for tail sampling something?
Can you actually repeat the?
So
Yeah, so like, what's like can you give like a real world example of like the benefit of doing tail sampling the way that you do with like exporting the span metric exemplar and like using that in like the tail sampling process?
Oh yeah. So one.
and if you could repeat the question.
Oh, sorry. Yeah. So,
'Cause
what is
I
the
cannot.
what is the real world benefit of not using the in-memory tail sampler versus doing it with exemplars? So there are two benefits. The first one is that exemplars are a representative sample, especially in cases of latency profiles, because you think about what are the buckets that you want to define. You define all those buckets, and the instrumentation library makes sure that those buckets are being filled with exemplars every time a latency actually hits that bucket. So when you're sampling, given that you have that information, you're guaranteed that every bucket is going to have one of those buckets that are there, or the values that fill that bucket. And the second one is that again, long running spans. Like it's very, so if you're doing a 30-second memory based bucket for doing the tail sample, depending on how much traffic you're seeing, you need a lot of memory to do that. But in our case, like we have seen that sometimes a span can or a trace can take much longer than 30 seconds. In that case, widening the window means that you need more memory. But once you know these are all the interesting trace IDs that are upfront being announced, you can as well do like a select spans from table name where trace ID is in, and then like move it into another table. So all those things are possible when you actually have some predefined knowledge of what trace IDs are valuable versus what they are not, and we feel that exemplars are a good fit for that.
Awesome. Is there maybe one more question? I think we got them all.
Here.
Oh, right here. Thank you.
So, what's the bottleneck of your pipeline in your case? Like, what starts to break first if you increase your sample?
What is the bottleneck?
I think like with the autoscalers in place for most of the stateless things, I think like ClickHouse would be the place where if we run out of disk, then we'll have to provision more clusters and then make sure that we can keep spreading the traffic even more. But other than that, given that we have gone through the exercise of tuning the collectors and whatnot, it's easy for us to do some autoscaling there.
So it's storage?
Yeah, storage, yeah.
Awesome. Great. Let's do another round of applause for Vijay.
Thank you.